evaluate the sum of n going from 2 to infinity of 8 times negative 1/3 to the power of n. So there are sort of 3 steps we have to go through here. Step number 1 is going to be to determine the common ratio which is, you can think of that as the multiplier. We are going to refer to that as r. Step number 2 is going to be determine a, or that's the first term. So a is the first term in this sequence. And then step number 3, calculate the sum. And so here we're going from 2 to infinity, so we're going to refer to that sum as the sum as we're approaching infinity. So the common ratio, to determine that, we're going to expand the following expression so that we have the first 2 terms, because we're going to end up dividing those. So we can write this as 8 times negative 1/3 to the power of n starts at 2, plus 8 times negative 1/3 to the power of 3. So those will be the first 2 terms in this sequence. And it continues to infinity. To determine r, we would take the second term and divide it by the first term. So this is the common ratio. Okay, so the second term is 8 times negative 1/3 cubed over 8 times negative 1/3 squared. We can now cancel the 2 8s, and just using the exponent laws we can subtract the exponents, or we can also think of it as these 2 negative 1/3 cancel against 2 of the negative 1/3 in the numerator, so we're only left with one single negative 1/3. So r equals negative 1/3. Now, since r is greater than negative 1 but less than 1, it means that this infinite series will converge. So that's our r. The a, well, that's the first term. So a equals the first term. And in this case, the first term was this one right here. So it's going to be 8 times negative 1/3 squared. Now we can evaluate this, so it's going to be a little bit shorter and cleaner. So the exponent law, power of our quotient, which means we're going to get 8 times negative 1 squared is just 1. 3 squared is 9. And if we multiply the 8 in, we're going to get an a value of 8 over 9. So that's our first term. And then the third step here is to determine the sum as this series goes to infinity. The equation we're going to use here is the sum as we're going to infinity equals a divided by 1 minus r. So it's just a matter of plugging in what we have. A is 8 over 9. And r was negative 1/3. So if we evaluate this, in the numerator we have 8 over 9 In the denominator, we get the common denominator of 3, so it's going to, and the minus and minus becomes plus, so it's going to become 3 plus 1. That is 4/3. We rewrite this as a multiplication, so the numerator times the denominator, the reciprocal of the denominator, so 3/4. Okay, and we can reduce this to 2/3, and that's going to be the sum of the following infinite geometric series as n approaches infinity.